Assalamualaikum warahmatullahi wabarakatuh to Dr. Syadil. We are from Group 4, consists of me, Aiman Ibn Baharudin, and Nurul Safia binti Mustafa, would like to present our final group assignment for DEN 1213. Safia, can you go to the first part? Okay, for the first part of this, for the first part for the assignment, the appliance used is air conditioner, which is the Toshiba air conditioner non-inverter R32 1.0 HP RAS H10J2kg-M. As for the light bulb we use is BTG E27 compact fluorescent bulb. For the fluorescent light we use LED tube light F15T8 RV light bulb. As for the ceiling fan, we use the Deca Krypnos F10 56 inch. For the television, we use the Sony KDL 48 watt 650D 40 inch TV. And last but not least, for the wall socket, we use G1 power USB single switch wall socket. Okay, for the first part of the question, for the first part of the assignment, we need to determine whether the electric wiring connection uses parallel or series connection. So we decided to divide the circuit into sections where there are parallel circuit, but it is in series to other sections, which mean in section A, the rooms are bed 3, bed 4, and home theater, which is in a parallel circuit. For B, we use family room, alfresco, dining room, kitchen, and pastry room, which is parallel circuit also. For section C, there are garage, living room, court room, entry, porch. For section D, there are walk-in room, ENS, WC room, master suite room, and lastly is E, which is the bathroom, PWD room, dining room, the laundry, broom room, and bed 2. All A, B, C, D, and E sections are in series circuit, but the rooms in each section is in parallel circuit. Okay, Safia, can you go to section 2? Okay, for the section A, for the circuit A, we use the same circuit for bed 2, bed 3, bed 4, master suite, living, and dining, which is consists of one air conditioner, one ceiling fan, one fluorescent light bulb, and 2 wall socket. But for the family room and home theater, we added a TV which is in series to the wall socket. As for circuit B, there are 2 appliances used, which is one ceiling fan and one fluorescent light. For in B, there are walk-in robe and also alfresco. For circuit C, which consists of 2 fluorescent lamp, which is in the garage. Okay, Safia, can you go to the next part? For circuit D, which consists of one light bulb at the bath, PWD, ENS, WC, porch, coat, linen, broom, and entry. For circuit E, consists of one light bulb and 2 wall socket at the laundry and pastry. And last but not least, at circuit F, which consists of one fluorescent and 2 wall socket, which is at the kitchen. The symbol A, K, S, F, B, and TV, which is used in the circuit, is displayed here with also the power, voltage, and also the resistance of each appliance. That's all for part 2. For part 3, for the second part, we need to calculate the total resistance for each circuit. For circuit A, the total resistance we acquired is 1.073 ohm. The calculation is displayed there by using the formula R1 times R2 divided by R1 plus R2. As for the total voltage, since they are in parallel, so the total voltage is same across the circuit. So the total voltage is 510.4 volt. For the total power, it is 867 watt. For the total current is 9.962 milliampere. For A star, the total resistance is 1.624 ohm, and for the total voltage is 529.9 volt. The total power is 942 watt, and the total current is 6.575 milliampere. As for circuit B, the total resistance is 110.448 ohm. The total voltage is 270 volt. The total power is 82 watt, while the total current is 0.097 milliampere. For the circuit C, the total resistance is 64.5 ohm. The total voltage is 60 volt. The total power is 40 watt, and the total current is 0.1666 milliampere. For D, the total resistance is 3,200 ohm. The total voltage is 240 volt. Total power is 18 watt, and the total current is 3.339 microampere. For the circuit E, the total resistance we acquire is 1.100 ohm. The total voltage is 250.4 volt. The total power is 43 watt. And last but not least, the total current is 9.715 milliampere. Lastly, the circuit F, the total resistance is 1.091 ohm. The total voltage is 40.4 volt. The total power is 32 watt, and the total current is 9.795 milliampere. This is the total current, total voltage, and also the total current and the total resistance for all the rooms, for all the rooms in our assignment. Okay, Safia, can you proceed to part 3? For the third part, we used the Malaysia electricity bill rate is RM 0.24 ringgit per kilowatt. We obtain this bill rate from the link given, which is at the globalpetrolprices.com, Malaysia electricity prices. The total power for the circuit A, across all the total circuit and room is A plus A prime, A star plus B plus C plus D plus E and plus F. For the first circuit A, there are 6 rooms, therefore it is 867 times by 6. For the A star is only 2 rooms, which is 942 times by 2. For the B is only 1 room, which is 82. For the C is only 1 also, which is 14. For D is 9 room, which is 18 times by 9. For the E circuit, which is 43 times by 2. And last but not least, for the F, there is only 1 room, which is only 32. By multiplying and adding on all the total power, we will obtain 7,462 watt. But we need it in kilowatt, therefore we divide it by 1000, making it 7.462 kilowatt. The electric bill for 1 day from what we obtain, we will get RM 1 ringgit and 79 cents. But the third part, it requested for only 1 hour. Therefore, because 1 day consists of 24 hours, therefore the RM 1 ringgit and 79 cents divided by 24 will get RM 0.075 cents. Okay, as for the fourth, fifth, and sixth part, Safia will be explaining it. Thank you.
Assalamualaikum, Dr. Shahril. I'm Safia and I'll be presenting the fourth and fifth part of the report assignment. In this part, we are about to compare the calculation of the manual and the simulation. So we are using the formula V equals to IR, which is voltage equals to current multiplied by resistance. So in this formula, we can convert it into R equals to V over I to find the resistance, and also can be converted into I equals to V over R, which is being used to search for the current in the circuit. So through the manual calculation, the maximum voltage, total voltage that we found in the circuit A star 500 to 29.9 volt, and the lowest total voltage is 40.4 volt in circuit F, and using this using the voltage, we can
We can also find the current and resistance.
Also can find the current and the resistance using the formula above, and through the simulation in multisim, the circuits were a bit different than the manual, because the unit the value was in milli unit, and one
micro.
of the current is in micro unit, which conclude that our manual and simulation calculation is a bit
Different.
it's different. Next, the sixth part is shown in the comparison of the circuit sketch and the screenshot from the multisim circuit. The multisim circuit, we found the value of the current is about the same through each part of the parallel circuit, in every circuit. So
voltage also.
And the voltage is also the same in the each part of the each line of the circuit. Some of when there's one the one that that connected as a series circuit is socket 2, and TV as in circuit A star is divided. The current is divided, and it's become smaller than the parallel one. Even the voltage is different. I mean, like the socket and the TV, if we calculate the make it total addition of the voltage, it will
Be different.
it will be the same value as the I mean, like 3.233 millivolt plus 7.41 millivolt will equal to 10.683 millivolt, which is
the same as the others.
Which is yes.
Waveform. So
the waveform of each circuit, it's shown the same waveform. There is no difference. The amplitude is the same. The period shown in each graph is 3 period. That is all from our group. Thank you.
Thank you, Doctor.
Thank you.